Okay, looks like I've got some sound, and as promised, I'm pre-recording the Wednesday, uh, November 1st session. Of course, today is October 31, Halloween Day, also the day that Martin Luther posted the 95 Theses on the door at the church there in Wittenberg. Of course, he had sent his 95 Theses out, or points of discussion, to just about anybody who's anybody in the Catholic Church. So it was, news traveled fast compared to well, news didn't travel fast like it does today, but they got the letters, and the next thing you know, we're having a Protestant Reformation. So a very important day. It's the 500th anniversary of Martin Luther performing that, posting the theses on the door of the church at Wittenberg, and thus starting the Protestant Revolution. Well, as I told you yesterday, today is Tuesday the 31st. Yesterday I told you that I was going to I've got a dental appointment tomorrow, and I can't tell you how if you're like me, yeah, you love dental appointments, don't you? Anyway, to make a long story short, I'm going to record a session for Wednesday, and I'll post it for you to see, a pre-recorded session as I had promised. I will try, if possible, to do a second pre-recorded session. I'm not going to make any firm promises. I may try to do it Friday afternoon, maybe later today if I get the chance. It just depends. I've got some other pre-recordings I've got to do. Anyway, we talked about single arbitrary and what was going on with that. And now we're working on that support center case there in the Data Smart textbook. Okay, it's chapter 9 over at page 335. And I talked about that yesterday. In this case, we're going to explore a way to identify outliers. Okay, and I kind of reviewed the approaches that we've taken with the other two cases out of the Data Smart text. And as I mentioned before, I have two PDFs here where yours truly provides you basically what you would say if I wrote on a blackboard or whiteboard, the stuff that's going on, what you need to know and know about. And so I have that all set up for you. Now, also I have a calculator here that lets us, once we've computed those z-scores, which we're going to do in the case, then you can take it and you can say, okay, what's the probability I would get that z-score? Because when you look at standardized scores, or what we might call the Gaussian curve, well, any distribution, we're always talking about the probability that that would occur. For example, in the so-called bell curve or the normal curve, you can if it's normally distributed, the so-called bell curve or Gaussian curve, roughly 68% of all observations will fall between one standard deviation above the mean and one standard deviation below. Then you can add 14% on for two standard deviations above, okay, and 14% for two standard deviations below. So roughly you're now looking at between them, 34 and 14 for the first two above the mean, 34 and 14, okay, below the mean. And so we're looking at 96% of all observations will, if they're normally distributed, will fall within the mean, and two standard deviations above the mean or two standard deviations below. Then finally, when we get to sigma 3, or 3 standard deviations above the mean or below, about 2%. And those 2% add up to give us that roughly 100% of observations. So we try to, now we're going to look for outliers, and we're going to see a technique that we do that, and a technique that allows us to use standardize, and we're going to use that function. We'll talk about that as we go through the support center case. Before I do that, I wanted to point out some things that you have coming up that are due. Don't forget on the 3rd, which is Friday, you have Hammond's port number 1 is due. Obviously, of course, the Support Center XLS stat file from DataSmart. So this is a case from DataSmart, the form and text, okay? This Hammond's port 1 is from the management science text, and you'll want to do it as well. Now, I'm going to take just a few minutes and talk about it just a little bit because I didn't do much last. I don't feel like that I really gave it all of the time that it deserved on in speaking about it. So I'm going to start with Hammond's port 1, and again, these are over in chapter. These are over on pages 561, okay, to 572, and we'll pop over there. See if you ought to have your book with you. So it's over from 561 over all the way through to 572. Now, again, it's a waiting line problem, okay? And we're going to take a look at that. And I want to give you, I want to make sure, I cannot encourage you enough that you need to have the textbook with you when I do these sessions. If you don't, you're cheating yourself, okay? Now, I know I post the key up there and give you an explanation, all that business, okay? But folks, if you don't have your book and maybe take some notes, you're really going to miss a lot of important points about these cases and what we're getting accomplished. And these are extremely valuable skills for you to have. So here we're talking about over on page 561, the textbook, they talk about the waiting line simulations, okay? And they talk about static simulation models versus those that are discrete, okay? Also known as a discrete event simulation. And that gives us an introduction to Hammond's port. Remember, in management science, we try to find a model and we try to use it to do problem solving and decision making. And in this case, what we're trying to do is to simulate customer arrival times, okay? Remember when we went when we had single arbitrary, just the basic model of people show up, we service them, they leave, okay? That's the simplest model. We have control over the service time, but what we don't have control over is when they arrive. What we also don't have control over is how long will they wait in a line to be served. I've provided you some resources here, okay? This first one will help you put into perspective how important this stuff is, okay? The world you're going into, the competition is global in nature, and competition is driven primarily by analytics. Okay, if you take the business policy course with me, you'll get a heavy dose of analytics and a heavy dose of the book Competing on Analytics, which I think is probably one of the most important books that's been written in business the past 20 years. Then here's a resource about why we won't wait and how we lose profits and we lose customers by decreasing wait time, and how we decrease wait time and gain customers and improve their satisfaction. Then here's a resource that talks about how long will customers wait, okay? If you look around and think about yourself and like everybody, okay, we live in a world of instant gratification. We live in a world where people have 300 channels on cables, and they want to go and find one. And people, we have Hulu where people say, well, I want to see this series or whatever. And so we have that. We have a world that's like that. And so business really does have to adjust to the fact that people just simply will not wait very long, especially in a retail environment. Okay, and so Hammond's port is one of those. And so what we're going to try to do, okay, is since we have no control of when people come, we can try to simulate their arrival times. And that's what Hammond's Port 1 is about. Now, I want to open this up for you here for just a second. You said, Dr. Harmon, you sound really torqued about this. I am, okay? And I'm going to tell you why. Most of everything we do here in this management science course, in one way or the other, is applicable to what I think are some real employment and growth opportunities, and that is in logistics. You know, only 7% of all goods, okay, that are sold in the United States are sold through e-commerce. I told this to the MIS class yesterday. Only 7%, but that percentage is growing every year. And you know, when people buy stuff online, yeah, they got to get it. So that's logistics and distribution. If you're a marketing student, you live or die by distribution. Does the stuff get to the customer on time? Was it packaged appropriately, etc.? So there's a lot of stuff here, and there are going to be some of you who are going to go out in the job market, and frankly, you may find a lot of doors closed to you, except for some entry-level management positions at distributors, at delivery companies, at logistics firms. And listen, those are going to be some great opportunities in the future for everybody who's involved. Well, here I give you the assignment, and I ask you to upload Hammond's Port 1, and you're going to use GoalSeek to obtain a probability of weighting to 0.55 by changing the largest value for inter-arrival times. Then I ask you to use GoalSeek to obtain the maximum waiting time to 9.5 by changing the mean service time. Okay, and as I mentioned to you, Hammond's Port 1 is shown on page 567. And as I mentioned, to really get this, you're going to have to review pages 561 to 572. And I'm just going to give you a quick tour. They walk you through about customer arrival times and how those are calculated. Okay, and they walk you through the formula for that's over the middle of page 562, and then they show you inter-arrival time, okay, in minutes. And this is Hammond's Port with they have ATM machines. And then they show you at the top of page 563, the authors show us a standard deviation. There it is, a bell curve, the service time in minutes, standard deviation of a half a minute, okay? And then they show you at the very bottom of page 563, the simulation model. And you notice if you go right, and I'm looking at figure 1213, and you notice that the number of ATMs, that's controllable. The inter-arrival time, that's probabilistic. The service time is, you think it may be controllable, but it's probabilistic in the case of an ATM. You say, why is that? Well, a customer may have to do more than one type of transaction when they come to an ATM. You don't know, okay? So you have no idea. They need to make multiple transactions, okay? So you can't, you just can't say, well, here's the service time. Okay, so we assume that that's probabilistic. And then we have the output, and that's our operating characteristics curve. And if you want to see this, how it all unfolds, okay, here's another management science tool, and it's figure 12.4 over on page 564, that walks you through the simulation model. So there's a flow chart that shows how we put that all together. Okay, then then at the bottom of page 565, they show you the simulation results for 10 ATM customers, and they walk you through the inter-arrival time, the arrival time, the service start time, how long they wait, how long it took for them to be serviced, that's the completion time, and the time in the system, okay, is equal to, okay, their service time plus any wait. And then as you come down to customers, you'll see that waiting time and the service time, and you'll see how that all unfolds. And those details are all over here on page 566. They show you that, okay? And they walk you through customer 1, customer 2, customer 3 as part of those whole. And they just walk you through the step by step by step, the amount of time. Okay, so that's what's due for you. And I'm going to ask you to change some variables. All right, now this is chapter 12, so let's talk about this for a minute. I get the usual question, where will I find the file? Okay, all righty. I think we're learning, kind of figuring all that out. We're going to come down here to the MIS web files, and we'll download those. I want the MIS files. I'll download them. Okay. And then if I go over to chapter 12, I'll see the Excel files, and I'll see Hammond's port 1, and then you take it from there. Okay. So you've got that assignment, and they show you the simulation there at the bottom of page 567, showing the Excel worksheet. Okay, and notice something. Now, it's important for you to understand something. The numbers in the web file, that is the enter arrival times, those are volatile. And so, well, what do you mean? Well, okay, let's look at it for a minute. We'll download it again. And I'm going here to chapter 12. And look at Hammond's port 1. Okay. Now I'm going to enable the editing. All right. Now, let's look at this for just a moment. Notice the formula. B4, okay, which is the smallest value, plus rand, we're using the random function, times B5, which is the largest value, minus B4. So we're generating randomized arrival time, enter arrival times. Okay? And you might say, what's the difference between the arrival time and the enter arrival time? Okay? And when we talk about the enter arrival, that's time between successive arrivals. Okay? Now, they talk about that over the top of, in the middle of page 562, the authors do, but we call it enter arrival time because it's the time between each iteration, or each customer, if you will. And you can see customer 1, their enter arrival time is 2.3 because they're there in 2.3. Then you see the enter arrival time for customer 2, and that's 2.4. And the arrival time now is 4.6 because you add those two, the enter arrival time and the arrival time, to get 4.6. Okay, and then you just continue on as you add those on. Now, so the enter arrival time, okay, is the time between two successive arrivals. Okay. So we're concerned about when people arrive and then how much time expires between the time they arrive. Person A arrives, then person B, and we want to know that time frame because we're servicing person A, and this starts to tell us, okay, well, how long will person B have to wait? And they give you the equation there, there in the middle of page 562. Okay. And they show you a uniform probability, which is highly unlikely, and then they show you a normal probability distribution. And so what we're doing right there in column B, rows 16, column, the array of B16 to B1015 is we are generating 1,000 enter arrival times, and you'll notice we have all the way up to customer 1 down to 1,000. Okay, and we just have all of those customers hidden. All right, because if you look down here, you're going to see row 20, and then you'll see row 10, 11. And we just hid those rows. They're still in there. We just, for purposes, we just kept it, collapsed all of those. And then you see the summary statistics. So that's Hammond's port 1, and I've told you what you're going to need to be doing in order to complete that assignment. Now, you would be smart to go into the modules area. I'm just going to tell you this right now. You open the file, you go back over here to the modules. Okay, come down over here to the Hammond's port 1. I give you this verbiage, and if I were you, I would cut and paste this and put it into the file I'm working with. Okay? So that's what we're going to be doing with Hammond's port, and I'm going to go ahead and close that off. Okay? And I'm going to save that. All right, now, let's go back to the module because we're going to be talking some more today. And let me stop here for just a minute before I go any further. To really grasp and understand simulation, you really do also need to put in, you need to get ready to put in some time on reading this pretty intensively. This page 561 to 567 is one of the best narratives or passages I've ever seen on this topic, and how you can use, and you can use this about in any kind of service situation. Okay, so it's a fantastic tool. And there on page 568, you can see a histogram, okay, that shows a waiting line for 900 ATM customers. Okay, so I really want to encourage you to dig into that material and really master it and take a look at it. Okay, well, that takes care of the Hammond's port 1 and that assignment. And again, we'll come down here to the module. And you had, I showed you the single arbitrary key, and there's also a recording link to it. And here are the notes for Support Center 1. Okay, and that's that case over there in Chapter 9 of the Data Smart text. And it starts over on page 335. And as you recall, this involves finding outliers. Okay, and this involves, and it really starts over. You really want to start over page 341, okay? And I give you some information here, and this is Support Center Part 1. Let's take a look at it real quickly. Now download it. It's in a PDF. Okay? And what I do is I walk you through, okay, everything in that case, how everything's put together, and then how we compute z-scores. Okay. Then here, of course, is the normal distribution or Gaussian distribution, and then using the distances, because we're wanting to see distances between employees to see who is out there, who's an outlier. Okay. So you'll want to take a look at those notes, and maybe as I walk through them, have them diminished down or take a look at them. Okay, and then I show you here the distances tab, and again we're using Euclidean distances, and I'll walk you through the rank function and how it works, etc. So you're going to see all of these notes. It really wouldn't kill you to print them out and have them with you as you look to print them out and have them as you look at as I go through the lecture on them. And I have the notes with me, so I can remind myself, okay, this is what's going on. I'm going to close this off here, okay? And let's go back over here. And we're going to get that file, okay? And let's pop down here. Now we're going to get the file. Now, before I go any further, also let me note. Well, I'll talk about this stuff with you next week. But as you can see, there are some great resources out there, and we'll talk about Hammond Support 1. Now we're going to work on the support center case, okay? And this is this is the one that deals with the outliers, okay? And notice that that case, all right, the support center SLX, Hammond Support 1 is due, okay, and then the outliers, that's this case support center SLX is due on they're both due on Friday. I've got some multiple due dates in there for some reasons I don't, but for got a couple of people I don't want to go into it, okay? But just for everybody except for maybe a couple of people, you have a due date of 11/3. Let's look at the support center XLSX, and I always will get, where do I find the files? Okay, I'm going to say this one more time. When we're working with the Foreman text, the Data Smart text, okay, if you go over to page 36, they will tell you how to get to the website to get the files. But being a nice, wonderful person that I am, I've provided you the files. Okay, here they are in the Foreman files zip. Now, one of the things to me that makes this course such an exciting course is that I think that if you're a management major and you leave school and you don't go out and talk to an employer about the fact that you've had all of these information systems and technology courses, that you've worked with just about all of the major database products, that you understand about optimization and you've worked with those techniques. We have these BISS courses, and then this management science course really is the cherry on top of the sundae. And you can say to an employer, look, I have some great people skills. I understand how organizations work. Plus, I have some great analytical skills that are very valuable. I understand databases. I understand spreadsheets and what they can do. I understand about optimization. So if you're a management major, okay, I'm going to tell you right now, this stuff's gold. And I encourage all of you, if any of you who are in this class who are my advisees, if you're not out there checking logistics firms, okay, distribution firm, and if you're a marketing minor, if you're not a marketing major, you're not doing that, you're missing the boat, because we've trained you very well. You may not realize this, but when you leave OBU with your degree in business, you have essentially the same skill sets as a beginning data business department, as a beginning business analyst. Okay, so you leave here pretty well tooled and ready to go to work. Well, here's the Foreman files. Okay, and we'll open that up. And there's the famous mandrel. And now we're down here in chapter 9. We'll open it up. All right, and there's the support center file, and we're going to open that one up. And we're going to talk about it. Okay, now, and we're going to have to open this up with Office. What I should have done was download this silly thing. I'm going to close this off for just a minute. Well, it's open now anyway. Okay, you'll want to save it to your desktop. Okay, so you can do that. And I'll close that one off. That one off. And I'm going to enable the content here. I should have just, let me close this silly thing for a minute, because we're going to get all kinds of freaky stuff going on because we've got that randomization in there. That's the problem. All right, save it now. Here's what I'm going to do. I'm going to do support center, and I'm just going to take that file, okay, and close this off. All right, and I'm going to put it down here on my desktop. Okay, and your support center, and you should be ready then once you have it. See if I can find it now. A copy of support center. All right, and you'll want what you're going to want to do is download the silly thing to your desktop. Let me see if I can find it. I stuck it somewhere here. I have a messy desktop, don't I? That nasty. There it is. And I'm going to open it up, and then I'll save it. Okay, and don't forget, it's got that random. It's got those random numbers in it, so they're volatile, and so it's going to take a little bit of time to open up for us. Okay. There we go. And then you'll want to save it. All right. So you can upload it. Now, again, we start off with the employee ID, then average tickets, okay, per day. And then, of course, we customer ratings, etc. So this first tab, the support personnel tab, is the raw data. All right. And we have them all. I think we have 400 or some odd cases here. And here we compute the mean, part we count the average number of tickets and the standard deviation, which means that all things being equal, about 68% of all of these employees should have an average number of tickets a day between about 160, which is one deviation, standard deviation above, and 152. Which is one standard deviation below. Okay. Now, knowing that we're working with counts, okay, and because it's Halloween and Count Dracula, we have to be careful of him or her. I don't know if they have. I guess I always grew up Count Dracula was a guy. Okay. Times have changed, folks. I know I'm an old guy. What can I say? Standardized, and we're going to standardize those data, and we use the standardize function in Excel. I'm going to click on here and see it. And so we're cleaning these data up by standardizing them. And the way it works is there's the number that there's the data point we choose, and it's support personnel B2, okay? And it's in that support personnel tab. And then we get the mean, which was at row 402, and we get the standard deviation, which is at row 403. So we standardize that, okay? Now there's a help on this function which explains what it is, okay? And it gives us a standardized score for that formula, okay? And click that off. There it is. Now, we do the same thing for customer rating. We do the same thing on tardies, graveyard shifts. So we're standardizing these pieces of data. Let's go down to the bottom here, okay? And you'll see we're not doing anything. We're already applying summative data. Got it? Okay, so we've got these 400 employees. And we standardize the data. Once we standardize the data, then we can process it, okay? And this is where we go into the distances tab. Now, look, folks, as I said before, and I'm doing it right now, okay? I have my notes that I printed out about each of these tabs and what they do, okay? so I can really follow along and see what's done. Now, what we're doing at this point is we're computing the distance between each of these employees, okay? And we're computing that distance using the Euclidean method, okay? And this is the distances. This is in the distances tab, and that's over on page 4, I think, in this first set of notes or the second set of notes. Okay, and we use the square root. Okay, and that washes the data, and we get the sum of the offset. Okay, and the offset just simply what it lets us do. The offset function is it basically creates an anchor. It creates anchor cells, okay, and the number of rows and the number of columns, okay, and you could see that if you go in there and you look at offset. Here's what I'm going to do. Now we've compared this employee, but it's this one, and there's the distance. Here's this employee versus this one, okay, and we're using these distances to see who's really separated from everybody, okay. Now the standardized as we walk through that, and I'm going to show you here in cell C3 what we're talking about, okay. The A3 refers to the A3 in the distances tab, okay, and that's a 0. That means 0 columns to the left or the right, and so that cell C3 it compares the employee 144624 versus 144624, and I would suggest you print the notes out just like I have, okay, so you can really see kind of how he's got this all put together. And so we've compared, and we're using the offset, okay, which gives us an anchor to do this. And you'll notice something, okay, if you come down, you'll see the diagonal. All right, and you see the comparisons of distances. Now, the cell in D3, okay, in that standardized tab, is the reference to D1, okay, and that's where it compares these two, and you'll see that D1, okay. Notice what happens over here. You're going to see E1, F1, G1 when you come to look at the distances. And then you're comparing this one versus 14462. So you see, we're comparing them against each other. And we're using he creates a function here by using the brackets. And if you want to see some more about that technique where you create your own function, go over in chapter 1 of the book, and he walks you through that process. So we're getting all of these distances between these people. So we're doing these comparisons with these 400 employees. Because we're looking for outliers. All right. Now, the next thing we're going to do is we're going to look at the rank. Now, again, we're using Euclidean distance to compare these employees, okay? And notice that we pull these from the standardized data and refer back up to distances. So we're just doing these comparisons, and we're using that Euclidean method. Now, when we get over to the rank, okay, at that point we start to rank these employees, okay, and I'm going to take this all the way back over here, okay, and in the rank tab, we use the rank function in Excel, all right. In the rank function, we have a number. That's the number you want to rank, okay. We have a reference. That's an array or a reference to a list of numbers, okay. And so we've got C3. We're wanting to rank C3. And in the distances tab, and we're using C3 to C3 to OL3 as our array, okay, and then the order. And if it's a 0, okay, if it's a 0, it's omitted, and then a descending order occurs. If you use a non-zero value, it creates an ascending rank order. Duplicate numbers get the same rank, and you can use a correction to handle ties, which is what we do right here with the -1. So we eliminate ties, or to handle them. So that's the rank tab. So now we've ranked them. So we've computed, we standardized them, then we computed their distance, and now we're creating rankings in terms of those distances. Okay? And so at this point, we're pretty much halfway through what we would do. Okay? Now, over on, I think it's either the first or the second, I think it may be, maybe it's the second PDF, but it's page 9. I show you this issue involving the end degree, okay, and that's, you know, the number of edges in a node and where something is placed. And I show an illustration of that, okay. So we're back to looking at, you'll notice we'll see we're going to look at K distance, then a reach distance, okay, and then we'll finally get we'll have a local outlier factor computed. I'll do that. Well, I've gone close to 50 minutes here. And so what I intend to do is I'm going to stop and let you kind of absorb some of this, okay? So you'll want to go back and look at the screen share for Monday, okay? And I'm going to call this screen share number part 1 for Wednesday. And I'll come back and do a second one so that you'll have 2 parts for Wednesday, because there's a lot here to absorb, and I want to make sure that I don't rush through it, okay? Well, folks, that'll pretty much do it. This is going to be part 1 of the Wednesday, and then I'll do a part 2 for Wednesday. Doesn't mean you have to see all of them on Wednesday. You could also look at them on Friday, okay? And this support center is the one that you're gonna upload, okay? So I'm gonna close this off here, all right? And I'll go back up here to make sure you understand. I will be putting in the announcements, okay? You have your screencast for Monday, October 31. What I will do is I will put up a screencast for Wednesday, November 1st. Pardon me. Yeah. For Wednesday, November 1st. And that should actually be October 30th. Let me go ahead. I'm going to edit this for a minute. This is silly. This is the screencast for Monday, October 30th. I'll edit this real quick. October 30th. I'll save that right now. There we go. Then I will create a, I'll call this screencast number 1 for Wednesday, November 1. And then I will create a second one that will be maybe another 20 or 30 minutes at the very most. But I don't want to rush this, okay? And I do want you to have a chance to walk through the whole thing and to see how it's put together, because there's just so much in this case that's going to be of such value to you. And this is a way that they rank these employees to look for outliers. You could use this approach and this whole technique with any nominal data that you put in there. You could just put in, you could change the variables basically, and put your data and use the and go ahead and use the formulas. The one thing he does in here that's a little bit different is, and this is important for you, is he creates functions. Now he's done that a few times, and so if you really want to kind of get a handle on how he does that, take a look over at page 5, over chapter 1, okay? And that's and he talks about spreadsheets, and he talks about how some navigational things, freezing rows, okay, copying formulas, okay, and he talks about creating using conditional formatting. And the pay special window and how to use it in Excel. It's really some advanced Excel techniques. VLOOKUP, filtering and sorting, and pivot tables. He also talks about how to create functions using the brackets, okay, to build your own functions, because that's literally what he does in there, okay? And I would encourage you to take a look at that and review it. All right, folks, thank you so much. I'm going to stop the share and record this, and this I will post this as screencast number 1 for Wednesday, November 1, 2017, and then I'll do another shorter 20 or 30-minute one probably near the end of the week, maybe earlier, and we'll focus on that, okay? Thank you so much, and I appreciate your hard work. Keep it up. So I'll stop the share now, and I'm going to stop the recording.